8051 microcontroller ICs are available in different packages. Here the diagram show dual inline package of 8051 microcontroller. 8051 microcontroller is a 40-pin IC. Most of the pins are with dual functionality, means the same pin can perform two different operations. For example, the pin number 10 can be act as an input pin and the same pin can be act as a receiver pin for serial communication. 8051 microcontroller have four input-output ports, port 0, 1, 2, and 3. Each port is with 8 pin. For example, port 0 contains pin port 0.0 to 0.7. Same thing is true for other ports. Pin number 1 to 8 are for port 1. This port is with internal pull-up registers. Port 1 is a bidirectional input-output port, means you can configure port 1 pin as a input or output pin. This port doesn't serve any other purpose. Pin number 9 is a reset pin. This pin is used to reset microcontroller to its initial value. When we apply logic load to the reset pin, microcontroller work normal. But when we apply high pulse to this pin, the microcontroller get reset, and for the proper operation of reset, we must apply logic high for at least 2 machine cycle, that is 2.17 microsecond. This requirement is fulfilled by reset circuitry. When we press a switch, logic high is given to RST pin, a value of capacitor and resistor. Make sure that the logic high is given to the reset pin for at least 2 machine cycle. Pin number 10 is a RxD pin used by serial communication to receive data from other device to microcontroller. Pin number 11 is a TXD pin used by serial communication to transmit data from microcontroller to other device. Pin number 12 is INT0 bar pin, which is nothing but external interrupt 0 pin. Pin number 13 is INT1 bar pin, which is nothing but the external interrupt 1 pin. External interrupt is given to microcontroller using these two pins. Pin number 14 is a timer 0 pin. Pin number 15 is a timer 1 pin. When the timer hardware module of 8051 microcontroller configure as a counter, in that case, the external event has to give to these two pins. Pin number 16 is a write bar pin. Pin number 17 is read bar pin. Both these pins are active low pin, used as a control signal for read and write operation when microcontroller communicate with external memory. Pin number 10 to 17 can be used as a port 3 input output pin. Port 3 is a bidirectional input output port with internal pull-up registers. Pin number 18 and 19 are used to connect external crystal with microcontroller to provide system clock. Pin number 20 is a ground pin. Pin number 21 to 28 are with dual functionality, means this pin can be act as a address pin or input output pin. If you want to interface external memory with microcontroller, in that case, pin 21 to 28 can be configured as a higher address byte pins, that is 8 to A15 pin. Else, these pins are used as a port 2 input output pins. Port 2 is a bidirectional input output port with internal pull-up register. Pin number 29 is a PSEN pin, nothing but program store enable pin. In 8031 based system in which external ROM holds the program code, in that case, this pin is connected to OE pin of external ROM memory. Pin number 30 is the address latch enable pin used to demultiplex address and data. Pin number 31 the external access pin. We can store the program code in internal ROM of 8051 microcontroller or external memory interface to the microcontroller. If you want to store program code in 8051 ROM, in that nothing but internal ROM, in that case you have to connect this pin to VCC. Pin number 32 to 39 can be act as a port 0 pin or address and data pin. If you want to interface external memory to the microcontroller, then the data pin and the lower address pin of external memory device is connected to pin number 32 to 39 of 8051 microcontroller. To separate out address and data pin of these pins, we need to connect external latch device to pin number 32 to 39. And to turn on and off this particular latch, we use latch enable pin, ALE pin. Pin number 40 is VCC pin. You have to connect power supply to this pin. On the basis of working of microcontroller pins, we get minimum requirements for proper operation of 8051 microcontroller. Since port 0 is without pull-up register, we need to connect external pull-up registers if you want to use port 0 as a input-output port. We want to store program code into internal ROM memory locations, hence EA bar pin is connected to VCC. In between XTL1 and XTL2, we connect crystal of frequency 11.0592 MHz to get operating frequency for microcontroller. And for proper reset operation, we required reset circuitry.